Hey guys, how's it going? In this video we're going to go over question 1 from the 2022 SQA National 5 Physics exam paper, so let's get into it. Question 1 says an aeroplane flies from Aberdeen to Glasgow. The aeroplane flies 140 km due south on a bearing of 180 from Aberdeen, then 130 km due west on a bearing of 270 to Glasgow. And you can see how Glasgow and Aberdeen are separated on the map here. A part 1 says by scale diagram or otherwise, determine the magnitude of the displacement from Aberdeen to Glasgow, and there's 2 marks available here. Well, we can use either the scale diagram or calculation method here, and I'm going to use the calculation method, so Pythagoras. So we've got a displacement vector south, and we could label that A, and that's 140 km, and then we've got the displacement vector going west at 130 km, and we can label that B. And these already join nose to tail, so we don't need to think about how they're going to join. We can then draw on a resultant vector going from the start to the finish point, and we can put a double arrow on that to make it different to the single vectors. We can then label that side C, and add in our right angle and then our angle theta next to the starting point. To find the side C, we want to use Pythagoras, so we could do c squared equals a squared plus b squared, and then substitute in the numbers. So we have 140 squared plus 130 squared, and note how we're keeping these in kilometres, so our final answer C needs to be in kilometres. And that's equal to 36,500 once you put it into your calculator. To find C on its own though, we need to square root both sides, so we've got C equals the square root of that, which is 190 kilometres. A part 2 says by scale diagram or otherwise, determine the direction of the displacement from Aberdeen to Glasgow, and again there's 2 marks available here. Well, again we can use either the scale diagram or calculation method, and I'm going to keep it consistent, so just continue with the calculation method. And remember, to find direction we need to calculate the angle theta first, for which we always use tan. So we're going to use tan theta equals opposite over adjacent, and opposite the angle we have 130 kilometres, and adjacent to the angle 140 kilometres. So that's equal to 130 divided by 140. And to get theta on its own, we need to do inverse tan or shift tan in your calculator of 130 over 140, which should give you 43 degrees. Now that's our angle, but remember, to get the direction we need to use compass points or bearings. And it's up to you which one you use. So to describe the direction with the angle using compass points, first of all, remember this is south down here and this is west over here, so we could say that the resultant is pointing 43 degrees west of south. So we've got 43 degrees west of south, or if you're thinking about bearings, remember we go to the starting point, we think about our north direction on a bearing of 0, 0, 0, and if you think of this as an imaginary line, we want to move round from the imaginary line from 0, 0, 0 all the way around until the resultant vector. So starting off here, we're going to cover 180 degrees to get round to this point, and then another 43 degrees here to get to the resultant vector, because we know the angle there is 43 degrees. So we can do 180 plus 43, which should give us 223 for the bearing. So we can say it's 43 degrees west of south, or a bearing of 223. Part B says on the return journey, the aeroplane flies directly from Glasgow to Aberdeen. The journey takes 0.50 hours. Part 1 says calculate the average speed of the aeroplane for this journey, and there's 3 marks available here. Well, writing down what we know from the question, we're trying to find the average speed v bar. We know the distance d is 190 kilometres. That was our resultant displacement from part A, and we need to change this into metres. So that's the same as 190,000 or 190 times 10 to the 3 metres. And lastly, our time is 0.50 hours, which we can convert into seconds. So changing that into minutes would be 0.5 times 60, and to get it into seconds we need to times by 60 again. So 0.5 times 60 times 60 gives us 1,800 seconds. Now writing down the equation relating average speed, distance and time, we have d equals v bar t. Substituting in the numbers gives 190 times 10 to the 3 equals v bar times 1,800. And to get v bar on its own, we need to divide both sides by 1,800. So doing that in your calculator should give you an answer for v bar of 110 meters per second. B part 2 says determine the average velocity of the aeroplane from Glasgow to Aberdeen, and there's 2 marks available here. Now notice that Glasgow to Aberdeen is the return journey, so they're flying back the way they came. So let's start by sketching the triangle we had for the initial journey from Aberdeen to Glasgow, because this is going to help us understand what's going on here. So without any of the labelled parts, here we've got a right angle triangle. Remember, this was the resultant vector, and we had our angle theta in here next to the starting point. And we're saying now we're going from Glasgow back to Aberdeen via a direct flight. And we'll just show that on the sketch here so that you can see what we mean. Now what I've done is I've put the 43 degrees in here that we calculated for the angle theta from earlier. And you'll see that I've written a new theta here, and this is because we want to now find the direction theta going from Glasgow back to Aberdeen. So we can now use compass points or bearings to define this angle theta. Defining it in terms of compass points, we would want to know what this angle in here is, and because we know it's a right angle triangle, all of these 3 angles need to add up to 180. So if this is 90 degrees here, this is 43 degrees here. If we do 180 minus the sum of 90 plus 43, then we end up with 47 degrees in here. So we could say that the angle this time is going to be 47 degrees north of east. And that's because the resultant vector now is pointing between north and east. Or we could define that in terms of bearings as well. Remember, we go to the starting point, which would be down here this time. We think about our north 0, 0, 0 bearing, and we move round from north to the resultant vector. So it's going to be this angle in here, which is just going to be 90 minus 47, which is 43 degrees. So our bearing would be 043. So to summarise, we have the average velocity would be 110 metres per second at 47 degrees north of east, or you could write it as 110 metres per second at a bearing of 043. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.